Namaskar, my dear friends. Let us say you want to simulate a circuit with different values of resistance. So suppose what happens is you are going to put a value of resistor R2 as, let us say, 2 kilo ohm. So that is fine. But however, now what we will do is we will try to give it a variable name and we will give different values to that x. Okay. So let us say R2 is x. So we will be trying to simulate that using a list of values that we want to put for x. Okay. Similar to that, we can have a random values as well, not a problem. I mean, we can have a linear values also, not a problem. Okay. Similar to that, if your variable is rx, the variable here must be rx. If your value is here x, okay, the variable here must be x. Okay, so this is how you assign the values for parametric sweep. So parametric sweep is very important because you want to find out the optimized value or the like very accurate value for a particular circuit, and this concept can be applied for any kind of circuit that you want to have. So let us say how it will look like. So it will look like basically like this. Let us say you have a value of R2 as 1 kilo ohm, 2 kilo ohm, 3 kilo ohm. Then for three values of R, you will have three different voltage values at this point V out. Okay. Similar to that, you can have a linear variations. For linear variation, it means this is the start value of R2, that is 5 kilo ohm, and end value is 20 kilo ohm at a step of 5 kilo ohm. It means 5 kilo ohm, then it will come 10 kilo ohm, 15 kilo ohm, and 20 kilo ohm. So this is how you will be having four values: 5, 10, 15, 20. So this is how you have four different graphs for output voltage. So what we'll do is we'll demonstrate this circuit in LTSpice and simulate it and see how it works. Okay. And for your understanding, what you can do is you can have this part as a screenshot with you so that you understand how to assign a particular value for single values. Okay. Let us say dot param x equal to 10 kilo ohm. Suppose you have given R1 as x, it means x equal to 10 kilo ohm. If you put, R1 will be given as 10 kilo ohm. Okay. Let us say you want to have parametric sweep, that is you want to put multiple values. It means there will be two methods. One will be linear variation and one will be random values that you want to put. Okay. So it means let us say this is your initial value or this is your start value, this is your end value, and this is your step size. Okay. So it will be having what, 10 to 30 at a step of 5 kilo ohm. It means what, 10k, 15k, 20k, 25k, and 30k. So this will be the values. Now let us say you don't want that linear variation. You want to have a list of values that you want to put by yourself. So in that case, you can have list word feed in here and you can keep that. So this is one of the best slide that you can have for your reference so that you can understand how to put a parametric statements. Also, this will also help you from analog devices. It was given directly. For linear variation, we have dot step. List also we have dot step. Then we have decade, octave for frequency variations. All right. So all these things are there. Anyway, it doesn't matter. We will directly go into the LTSpice and we will simulate this. Okay. So let us simulate this circuit and see how it works. All right. So we have one circuit opened. Okay, so what we'll do is we'll quickly put the circuit. Let us say we'll put a resistance division only. So resistance R1 I'll put. Press R to have the resistance. Okay. Then press V to have voltage. Press G for ground. And press W for having the wires. So wire it up quickly. So we have almost wired it up very nicely, right? You can cut it. Let us say W. All right, so we have wired it up. Now what is the first aim? First aim is put the voltage source. So let us say we want to put 5 volt or let us say 10 volt I'll put. Okay, so 10 volt calculation will be very easy. Now let us say this one I'll put 3 kilo ohm. Okay, now for R2 I want to vary this variable with different values. Okay, so first of all I'll just give it a variable name. So variable name must be inside bracket, inside bracket. Okay, the middle bracket. So put an Rx value. Okay, so this is my Rx. So this is how you have given a variable name to this. Okay. Now if you want, you can run it and let's see what happens. So once you run it, let us say stop time is 10 millisecond. Like I want to run it for 10 millisecond. Then put start saving from data 0. So what it is saying is Rx value is not defined. So if you put OK, you will have the error log. Okay, so you can see we have R2 node 002 and 001. In the middle of these two nodes we have R2, unable to find the definition of model Rx. So this is the error that you will get, and you can have this understanding for yourself. Okay, now let's cut it. So what we'll do is, to give Rx value, either you can go to this dot T, a spice directive. Okay, so either you click this or you put dot. So just press dot to go into the space, like a spice directive. Now let us say we want to put three values for that one. So what we'll do, dot step dot step, then param. And what is the next part that we have to do? What we have to do is we have to bring in the variable name Rx. And let us say I want to put 1 kilo ohm, 2 kilo ohm and 3 kilo ohm. K can be, like a bigger or smaller, that is not a problem. Okay, uppercase or lowercase, that doesn't matter. This is case insensitive. Okay. So this is how we have given the value of Rx, 1 kilo ohm, 2 kilo ohm, 3 kilo ohm. Okay. Now let's run again. Alright, so this actually cannot take because we have given the command for linear variation where step size is higher. So what we'll do is we'll just right click this and put here list. Means these are the values that I want. List of like 1 kilo ohm, 2 kilo ohm, 3 kilo ohm. So this is how now it will work very nicely. Okay. So just keep it closer. Now let's run it. Once you run, what is happening is you have the run window here, and let us find the probe it at the input voltage. So input voltage is 10 volt. You can see we have V node 001. Output voltage is 3 graphs are there. Graph 1, 2 and 3. All are same color. So to have different colors, what you can do is you can double click on this. So you have 3 different colors for the 3 voltages. You can see we have 6 volt here, and like around 5 volt here and 7.5 volt here. But you are not sure for which value of R these values are there. Okay, so right click on the graph and you will see you have nodes and annotation. So go to nodes and annotation and put annotate steps. So or this you are going to see this one. Okay, so for you can see 1 kilo ohm, you have first one, this one. So for 1 kilo ohm you can see this will be around 3 times, so 7.5 volt, that is fine. Similar to that, this is 2 kilo ohm, so 2 kilo ohm is 6 volt, right? It is fine. Similar to that, it is 3 kilo means half, like 5 volt. So this is nice. All right. If you want, you can right click on this margin. Right click on this margin as soon as the scale appears. Right click, and then what you can do is you can keep a top value of, let us say, 10 volt, and this one you can keep it 0 volt. So 0 to 10 volt it can give you at a step of, let us say, 1 volt. Okay. So you can see at a step of 0 to 10 volt, at a step of 1 volt, you are seeing 5 volt, 6 volt and 7.5 volt very nicely. All right. Okay, so since this no VN2 is not, like applicable or not understandable much, so what you can do is you can put a net name. So to get to give a net name, what you can do is press N or otherwise put a node. Okay, so this is called net. Okay, this is label net. So you put this label net or press N to get the label net, and I'll just put it as V out. So it will come V out here, and here I'll put it V in. So this will be my V in. Now let's rerun it. So what I'll do is I'll just delete this annotation. Now once I put probe, what is happening? V in is coming 10 volt. What is happening here? V out is coming. Double right click so that only 3 colors comes. So V out is happening 7.5, 6 and 5 volt. If you want, you can like come here and put a top and bottom 10 volt, let us say 1 volt at a step of 0 volt onwards. Okay. So this is now nice. Now right click on this and put the annotate steps. So you have 3 values for 3 graphs. All right. So this is how you can do a parametric sweep. If you have any doubt in like different kind of circuit, like you have MOSFET based circuit or maybe current resistor divider, so current division rules, voltage divider rule, any circuit is there, to differentiate these values of Rx, you can have this kind of understanding. Okay. Let us quickly vary this particular step parameter for like random values instead of having, sorry, for linear regulation. Okay. So linear, what you can do, you can right click this and you can put this one as comment. Okay. So let us say you put it as comment. So this has become like blue color. Now again go to dot parameter like spice directive and put dot step, then param, then rx, and after that you start with start value, then go to a stop value. Let us say I want to go a stop value as, let us say 6k at a step of how many, 1 kilo ohm. So I will put 1 kilo ohm step. So 1 kilo ohm, 2 kilo ohm, 3 kilo ohm, like that up to it will go 6 kilo ohm. So this is my like a step parameter for linear regulation 1 kilo ohm to 6 kilo ohm at a step of 1 kilo ohm. So R2 value will vary these many values. Now let's rerun it. So once you rerun, you have V out, these many values 1, 2, 3, 4, 5, 6. Now you can right click it and you can go to nodes and annotation and annotate steps. So for each value of Rx, what is the color that you can see? So let us say red color is having 2 kilo ohm. So for 2 kilo ohm, what will be the V out? 2, 3, 2 just 6. So 6 volt. It is coming 6 volt. Very nice. For like 3 kilo ohm, it should be 5 volts, because 3 kilo ohm, 3 kilo ohm, so half voltage will appear here. So 3 kilo ohm, it is 5 volts. So this is nice. So this is how you do the parametric sweep. Thank you.